Thank you everyone for joining us today for Data Theorem's webinar series. Today our topic will be how to automate mobile AppSec without the staff. Now before we get started, I just wanted to provide a little bit of background on who Data Theorem is. The company was founded in 2013 in the heart of Silicon Valley, and we're headquartered out of Palo Alto, California, with offices in Paris and in New York. Our executive leadership team has over 15 years in the cybersecurity industry, which has led us to have a great deal of success and given us the privilege to work with many great customers, as you can see here today. Now, before I hand it over to our speaker today, I just wanted to mention that we will reserve time at the end of the presentation for Q&A. So if you have any questions, please put those in the Q&A panel. With that, I will turn it over to Himanshu.
Thank you, Richard. I'll go ahead and see if I can get the controls working here. All right. So in the next 20 minutes or so, we're going to talk about how to automate mobile application security without an enormous amount of staff. If you do have the staff, some mobile AppSec teams or some security teams don't have any staff. And some of them that do, the staff is busier on more manual or strategic items that software can't automate. So those are one of the biggest challenges that we've seen growing in the industry for about 5 to 10 years. And we'll talk about how to deal with those challenges in the best way to optimize your budget, optimize your software, and of course, optimize your team itself. So the first thing you want from any security product, vendor, or program is to make sure you're solving the most important issues first. Now, when I was much younger, doing penetration testing myself for a company called AppSec, we would find security vulnerabilities, and our customers at the time would ask us, well, what's the risk of these issues? Like, what happens if someone were to exploit these vulnerabilities? And we would say the risk is high or medium or low, right? And you're talking about an industry 20 years ago that was very young, very new. And so to make it simple, everything became high, medium, low. And the word risk changed to severity, severities changed into exploits, and so on and so forth. And so what we have 20 years later is a way to fix issues based on data that may not be correctly aligned to what we're trying to do. So here, about 15 years later, what we're trying to do is challenge the way people are thinking about security vulnerabilities. What we're saying is like, hey, fix the most impactful issues first. I don't know about risk. I don't know about severity. Of course, I do know about those things, but often those things become data to argue with a developer about whether things should be fixed or not. I should fix this because it's high risk or it's high severity. The developer doesn't have those tools or words to challenge, and so what they do is they come up with story points and say, oh, it's going to be 20 story points or 10 story points. So now both sides are challenging each other with vocabulary that they can control, points or risk, and there becomes a political battle to get things done. So we've kind of taken a different approach. We've kind of said, hey, let's focus on things that are actually non-subjective and very clear in terms of fixing or non-fixing. So what you're seeing on the screen first is exactly our first priority, which is we call P1 vulnerabilities. P1 vulnerabilities are any issue that allows a remote attacker, and the key thing is remote. It has to be a remote attacker to export data from an app. If that is possible at any point during a security review, that is a P1 issue. And I think a developer could agree, definitely a security person agree that, hey, if we have a vulnerability that if it were to be exploited by a remote attacker could lose data, that is something we should all fix. That is a P1 issue. So that's the first thing that you want in your test case. You want that every day, every release, you want that checked for every day, and you want to see goose eggs at the end of that. Similar to developer test cases, when developers run test cases, they run them to see green lights. They run them to see a bunch of zeros, that nothing failed. It's a little bit different in security. Unfortunately, in security, we think if we see a lot of issues, that means good progress. That means the product is working. That means the program is working. And that's why you have security vendors that kind of, bump up the number of issues because they know that's what they're being measured on. We kind of have to change that. We kind of have to scan for P1 issues on a daily basis on every build to make sure it's zero. And if that's zero, we know we passed that test case. So that's challenge number one, and probably the biggest challenge that we always want to solve for our mobile apps. Challenge number two is the App Store itself. Now, again, when I was younger, there was no ecosystem to get a web app out to the internet. You just built it and you published it. Now we have a two-party system. We have Apple and Google, and at least in the United States, they do control what is on Google Play in the App Store. Now they have business incentives. They're both billion-dollar companies, so they're doing the right thing that's built for their businesses. But they also have security requirements that help out their customers and their app stores. So problem number two is more of a development problem, but it has a side effect on security. Both Apple and Google have a very low, but have a security bar. If you do not have, or if you do have security issues that both Apple and Google say, we do not want you to have those apps with those security issues in our app store, they can legally remove those apps from the app store or have the updates delayed. In either scenario, this is not ideal because now you have the gatekeepers, if you will, controlling the release of your apps, of your products. Now, both Google and Apple implement these guidelines inconsistently. We've seen that for a number of years where they'll block some apps and not block other apps with the exact same issues. Again, they're for profit, so many of their decisions might be for their own ecosystem. But nonetheless, having Apple or Google, the two gatekeepers, control the ability to update your apps, your products, is never a good thing. So that's problem number two you want to solve. Another unit test, right? So you've noticed I haven't said this is a high risk issue, app store blocker, or high severity. If you go to a developer and saying, if you don't fix this, Apple has a contractual right to delay your app from being updated on the app store. Again, non-subjective, very clear. Both parties can essentially agree that's not a good thing. And that's the second challenge or the Senate unit test that you want to implement. All right. The third unit test is, to me personally, one of the biggest. So when you talk about mobile app security, especially if you were talking about it in 2010, 2011, and 2012, the first thing you would hear from our good friends at Symantec and McAfee about malware and all these malicious apps and all this data that's being stolen. And I'll reserve my judgment and my comments on that category, but there is a sandbox on Android and iOS. Both of them have sandboxes. So when you download an app on your iOS device or your Android device, it is isolated from the other apps and its data and its memory and so on and so forth. So while not perfect, the iOS and Android operating system, in my humble opinion, are far superior than what I grew up in the late 90s on a non-isolated, not chrooted world, if you will. So my point with that is when you take that idea to third-party code, like third-party SDKs and third-party open source libraries, there is no sandbox. So all the energy people are spending on malicious apps, if you will, my counter argument to that is let's spend that energy on those SDKs bundled into your app and those open source libraries. Now I have nothing against open source. We have a very popular open source tool called TrustKit. So it's not the nature of open source or even commercial SDKs. Here's the deal. These SDKs and these libraries are unvetted business partners that have full control over your app, its data, its permissions, its network layer, everything. Your code and the third-party code sits next to each other in the app. That third-party code can do anything your code can do. So those those SDKs within the apps must be vetted. That's what we're saying. And we saw many news articles over the last 5-10 years where third-party SDKs, often commercial, not even, I know open source, depending on where you are in terms of finance or technology field, has a very good connotation or bad connotation. But what's funny is the commercial SDKs, in my humble opinion, are causing more of the problems. And the reason why is monetization. If I can get 10, 100, a million developers to use my SDK for free, what I can do is monetize the data that I get from these apps. This is the new monetization world. Now, when I was younger, again, monetization was not as complex. So when security people think about vulnerabilities, they think about hackers, they think about malicious actors, they think about nation states. These are all correct. But in today's age, a commercial entity with an SDK should be seen as an unvetted threat actor because they might be monetizing your customers' data for their own purposes. And so this is the third challenge that I think is often ignored is those third-party SDKs, they're unvetted business partners, and they just need to be reviewed. And they need to be reviewed, and those unit tests need to happen on, again, a per release basis. Because when a developer bundles those SDK, he or she is getting something out of it. They're getting analytics. They might be getting, UX recordings. They might be getting performance. They might be getting TLS. They're getting something useful out of it for quote unquote free. And this is a good thing for the developer. That's why you see 12 to 18 SDKs in every app. But what's the trade-off? And does that trade-off involve any security or privacy issues? If not, everything good, the unit test passed. If so, security should review those to see if it's a material issue or if it's a low severity issue, and you can move on. And then number four in terms of challenges, this is often ignored, but because it's not technical. We often worry about technical issues, the most interesting issues, and we're all human. Those are very interesting to listen to and read about. But often the media captures low technical items that have a wide scale impact. So there's an unwritten rule for most chief security officers that, hey, one of the reasons why I buy product or why I spend money on an information security program or why I hire staff is to make sure I stay out of the headlines. So it's funny, you won't see that as a feature. Well, one of our products you will, but in most cases you won't see that as a feature because people think of it as a non-technical item. But if you can keep your customers out of the headlines, you've done a good job to at least protect the brand and the security reputation of the people who work there. With all these big data breaches, it hurts the CEO, it hurts the CFO, it hurts the company's stock price. But let's take it on a more personal level. If you were at company X when they were breached publicly, your personal brand is hurt. When you go and try to look for a new job or try to do something different, people are like, oh, were you there when the 30 million accounts got breached? Yes, I was, but it wasn't my department, it wasn't my responsibility, but that hurts your personal brand too. So one of the core challenges is to stay focused on the most important issues, challenge 1, 2, and 3, but also not ignore some of the less technical issues that the media loves to talk about, and then making sure you're staying ahead of that as well. Now, enterprise concerns. So we talked about challenges, and these are all unit tests, 4 unit tests that should be done on every single release, but also that flips over to the enterprise as well, and also more unit tests. So the first one is very obvious. You do not have to hear it from Data Theorem. Regulatory compliance. You make sure you're in compliant, especially with mobile privacy laws. The FTC, GDPR, CCPA in California, the list goes on and on. Privacy is nothing new to mobile, but now there's finally, after 5 years, some teeth being sunk into it. So if you're taking geolocation, which a lot of people do for legitimate purposes, but how are you storing it and who are you sharing it with? That last part is the key part. Like, apps have been taking geolocation for a very long time for legitimate business purposes. Now, what if I'm using it for a legitimate business purpose, but I'm sharing that data accidentally maybe with that analytics SDK that is a third party housed in Florida, right? Or if I'm, housed in Florida and this is an EU app. That, if it's not in my privacy policy that I'm doing that, that's a GDPR violation. Because in GDPR, you must state that the geolocation or trackers, if you will, are being sent to a third party outside of the EU. So this is a very, very clear thing in GDPR, but it's sometimes in the technical world not so obvious because it just happens automatically. So regulatory compliance is a key thing that you need to keep a watch out because the list is growing by the day, especially on privacy. But what has happened in the last 5 years is always happening. So someone could say, hey, we've been taking geolocation for 5 years, but now finally there's some laws against that, and the fines are coming, left and right, as you can see, with large companies being in the news almost every month. The next enterprise concern is something traditional for security, which is data at rest and data in transit, right? Some of the biggest attack surfaces for mobile apps are not necessarily, in my opinion, data at rest, it's data in transit. Your users guaranteed will be on a hostile network using your app. We can all agree with that. Hostile, malicious, unknown, or maybe to simplify it, untrusted. Your users will be using a network that's untrusted, guaranteed. So what can your app do to be fully secure on an untrusted network? That's the world we are living in. That's the reality that security practitioners need to buy into because that's just the truth. So the key thing is making sure things like TLS are not only there, fully TLS apps, but also enforced. So there's obviously tools like SSL pinning. SSL pinning is a disaster on web apps. SSL pinning is awesome on mobile apps. So the ability to enforce TLS at all time on an untrusted network on an iOS and Android app is a very good thing and very achievable, unlike on web app. And it's something that we've done on an open source project with TrustKit for many years. This is a free open source tool that you can use at any time to basically enforce TLS. And then when your users are on an untrusted network being attacked, and we actually have statistics that over 100 million attacks on TLS on mobile apps alone have been done in the last 2 years. So the attacks are happening. So to make sure that your users are fully secured on an untrusted network is an awesome thing you can do, quote unquote, for free. And so that's one thing that these things are achievable on mobile that were not easily done on web apps. So let's talk about, now we'll move away from, the unit test and the enterprise concerns and talk about how traditionally organizations have done this and why may it not be the best plan for the future. So I always like to bring up this analogy, and again, being a security person for many years, when you show up to a developer discussion and you bring old tools and old methodologies, you kind of look awkward. You kind of look out of place, right? You're talking about DevOps, you're talking about developers, you're talking about releases, and then if you say, hey, we're gonna pen test the next major release, even that word, that we're gonna pen test the next major release, that's not a harmful sentence. But what it sounds like, it's like, wait, what are you talking about? We don't have major releases anymore. We release 30 times a day, 30 times a week, 30 times a month. We're always releasing. So then the developer, well, what do you want to test? What release? Well, what's new in this new the new release? And then you get to this discussion, and sooner or later you're having a very long conversation with when you just should be scanning and testing automatically. So what we're trying to say is coming to a meeting and talking about manual anything to a developer community that's doing weekly or monthly sprints, releasing nonstop, fixing issues, performance issues, availability issues, or hopefully security issues as they come up. That's the world people are living in. So when you come to that table, we highly recommend coming with tools that they have already adopted to, rather than them adopting to your maybe traditional techniques, which is maybe more manual, slowing things down versus like, hey, we can run as fast as a developer team, and here's the tools that we have for that. And then when you have those tools that are running fast, it doesn't have to be data theorem. Obviously, we run very fast, but there's a few tools out there that besides ours that do this. The next thing you have to do is Essentially, make sure you're measuring the success of the tool based on how developers run their organization. Again, earlier in the discussion, we were talking about unit tests. Unit tests are designed to be green. If something fails, that means that the release shouldn't happen and we should not proceed. Security has grown up the opposite way. The more issues, the better. The more issues shows progress and quality. And obviously, I have reservations of why I don't think that's true. But what you see in this kind of graphic is traditional tools, static analysis tools that were measured in the old way. And what we tell our customers essentially is like, hey, listen, we're not going to bombard you with a lot of code quality issues or nice to have issues. The quality is going to be high and the bug count is going to be low. So when you see something in this unit test that developers are running 20 times a day that shows up red, you can see that it's a real issue, that the build should stop. If it's all green, I'm not saying there's not issues. There's always going to be issues. That's the nature of security. But is this issue material enough to stop the release? Just like a unit test, a performance unit test. And if it's not, proceed. So in the graphic on the right, you can see quality needs to be the emphasis when you talk to the developer community, because you're just going to fatigue them with so many issues, and you will force them to do it because security has a lot of power, but that forcing function will give them basically ulterior motives to hide issues from you, to downplay issues, to upgrade story points from 5 to 25 to get out of the work, rather than saying, hey, we did 20 releases this week, we failed on one security unit test, we'll get it fixed in the next release. That's the conversation you can have, but it must be with real quality issues and just not a large number of code issues that you might get from traditional code scanners that you've used in the past. So automate. So now here's a list of things or unit tests that we provide to our customers. Now, this is not obviously exclusive to Data Theorem. Most mobile application security companies are doing some of these things. Obviously, we think we do more of it, but the point is static and dynamic analysis is a no-brainer. The key thing are the objects on the bottom. Your security program for mobile apps should have something like below. Should have a bunch of green, some red, and a little bit of blue. So the idea here is you have code scanning on the left, you have basically unit test in the middle, and then you have basically compliance and API and malicious scans on the right. I'm not going to go through each of these features that we provide because that's not the point of this call, but the idea here is you want to see green check marks across the board. Unit test, unit test, unit test. That's the language developers understand. That's what they grew up with. That's what you can relate to them. If you move fast and you say, hey, these are the unit tests for mobile AppSec that we're going to run, everything should show up in green, then you're speaking their language. And when things don't, we have a total of 2 blockers. We probably found, 35 issues in this scan, but only 2 of them are material. Compliance, you can see we found 4 in this typical scan. Compliance is a different avenue. You might want to block, you might not want to block, depending on if this compliance is something that you worry about. Like, for example, if you're not taking credit cards, a PCI violation is not something you guys should care about. Or if you're not a healthcare company, HIPAA is something you don't have to care about. But the point is this is the unit test framework you should have baked into your mobile AppSec program. Hopefully you see greens on every release and the developers are happy. And when they do see something red, they know it's serious and they know they need to fix it before the next release happens on maybe the next day or the next week itself. So obviously our answer to automate or address mobile app security without the staff is do not ask your existing staff to do what machines can do. Machines can do a lot. Now, they're not perfect. There's certain things that a mobile app automated solution cannot do. But the thing is, unit test for every release needs to be thorough, needs to be exhaustive, and needs to be real. So notice this is not a list of C code, Java or Objective-C code issues, right? That's the language of security. We have to speak the language of developers to make sure that we automate, and then the staff that we have, whether it's one person or 20 people, that we limit the needs of the staff and not slow things down. Your staff is valuable, but going to developer meetings, asking them what's the next major release, what features are in this release, talking about it, and then maybe pen testing it, not only slow things down, it won't scale. You know, developers will find a way to avoid that pen test as much as possible, versus if it's baked into the program on a nightly basis, then essentially it's there automatically, and the developers don't have to do anything, security doesn't have to do anything, it's just there and always works.
Perfect.
I'm going to hand it over to my coworker Richard to talk about a case study that we did with a large investment bank in New York, and their experience with this approach that we did for them.
Perfect. Thank you, Himanshu. As Himanshu mentioned, I'm just going to run real quickly through a case study we're doing with one of our customers and how they're leveraging automation to overcome some of the challenges we listed out earlier, and to help scale their limited security team with, obviously limitations in having short-staffed. So just to kind of highlight the challenges they faced, these are not unlike the challenges Himanshu brought up earlier, or the challenges we see across a number of our customers and a lot of the enterprises that are out there that they have to overcome with their mobile AppSec programs. The first for this organization was, as you can imagine, fixing any application level vulnerabilities and being able to continuously identify and address those at the rate in which their development teams were producing code. Second, being able to identify when something may be beyond a vulnerability, but actually block them from a release in an app store, and the ability to identify that and then go ahead and remedy it. Now, this third one is one that's pretty common amongst organizations that have lots of mobile applications out there. And that is that a lot of these mobile app teams tend to be developed across multiple product teams. And what we find in the example of this organization as well is these product teams all use different tools, especially when it comes to their development cycles. So their CI/CD tools vary, as well as things like their bug repository. And that can become a challenge for a security team who has a limited staff, who has to now work with a variety of different integration points and tools to be able to create their audit process to make sure that it's working within those development programs. And then lastly, obviously being a financial institution, this is something that comes up for them, but dealing with regulatory and government regulations around what they do, in this case, the FTC. If you didn't get a chance last month to see our webinar, which talked about how to automate compliance audits with limited security teams, I would definitely recommend checking that out on our website to get a little more detail. So how did they handle this, and what did they do to fix this moving forward, and how did they bring automation in? Well, past alternatives that they historically had used was manual audits. And I know Himanshu talked a little bit about, the difficulties with manual audits and where that is today. And then obviously having to deal with doing things like internal scripting to be able to work with all the different development teams that are out there. Now, as you can imagine, with having multiple development teams and having to do this in a very manual process, that tends to lead for them to become the bottleneck for a modern day release cycle, right? Where we have a lot of cases, we're seeing organizations like themselves and others releasing builds nightly, right? And having to go through this manual audit and this scripting across multiple teams becomes very time consuming, and it tends to lead to a bottleneck and a difficult relationship between security and the development teams. So what they did is they brought in a automated solution that provided the ability to integrate into the multiple CI/CD pipelines that they've had and do a continuous evaluation and scan of each of their different product teams and each of those mobile teams and a cadence that would keep up with their nightly build cycle. On top of that, it auto-generated the compliance reporting that they needed to be able to address not only the industry regulators, but also in some cases their own customers and their need to be able to show that they're in compliance and that they're taking these precautions with their own mobile applications. So as a result, they're now in a position where they're able to scan all of their apps in pre-production, so before they ever make it to a production release. Over the last 90 days, they've been able to close out over 75 security issues, 51 identified 51 and resolved compliance and regulatory issues. And the one that's really important to Data Theorem, and we believe is the most important, are being able to make sure that those top priority data vulnerabilities that remote hackers can exploit, as well as those app store blockers that can impact the business, did not make it to a production release. So that gives you a little snapshot of what automation was able to do for them in a 90-day period across multiple applications and product teams. So with that, before we kind of let everybody go, I just want to give everybody a moment to, if you haven't put a question in the Q&A, I'll give everybody a moment to do so. But while we do that, we do have one question, and I will give this to Himanshu. One of the questions that came up was, what is the trade-offs of using automation for mobile AppSec versus traditional manual pen testing?
Oh, wow, good question. Good question, straight to the point. Well, yeah, there's, like I said earlier in the presentation, manual pen testing can and still will find issues that automation cannot. I was a pen tester at Stake, started a pen testing company called AppSec Partners, so I believe in penetration testing. However, when I was doing penetration testing in '99, the amount of software releases using a waterfall method were months apart, not hours apart. So the trade-off, I would say, is when you have a fully automated, baked-in unit test for security like Data Theorem, the trade-offs are those really, really deep, interesting attacks that kind of play off each other, which is like if you do X, and then you do Y, and you do Z, and Z has nothing to do with X and Y, and you put all those things together, you have a root shell or something like that. Those issues cannot be found with automation. So that's the trade-off. So a lot of times customers use us in replace of penetration testing, but we always caution is do not replace penetration testing every release is fine, but not for every year. So it's not use one and not the other. So yes, we come in and we often replace penetration testers because of our speed, our accuracy, and our volume. But we still tell our customers that, hey, once a year, only for those very hard, sophisticated, multi-triage attacks, is you should have a penetration tester only to look for those. And I would say that's the biggest trade-off, because a machine cannot wire money to 2 accounts and then unwire it from 1 account and then log into a second account and see if they can reverse that wire and replicate it somehow, or so on and so forth. So all these different creative things that penetration testing can do, that's definitely the trade-off. And we still encourage that at least once a year with various pen testing teams out there. But obviously the positive of getting thousands of unit tests from P1 issues to open source SDK issues, and there's 10,000 SDKs to review, so that volume is a large volume. All those security unit tests you get about every release in an automated fashion is such a important need as in order to keep pace with the developer community, pushing out products there on a weekly basis.
Perfect. Thank you, Himanshu. It doesn't look like we have any further questions for today. So I encourage everybody, if you'd like to learn a little bit more, definitely go out and sign up for a demo. You can go to datatheorem.com/demo and do so. And I want to thank everybody for their time today. Thank you.